So welcome to the lecture video 26. In this video we will be talking about the formation of internet, or basically web, world wide web kind of structure using peer-to-peer systems. So we have already discussed distributed file system and universal file system both. Now in the distributed file system, as we had discussed, we identify a URI by which any file which is in the namespace of the owner or the user can be uniquely identified. So we decided that we will be using DFS, which says it's a distributed file system access, which we are making. And then we will put a owner's user ID, basically the email ID, because that's what we have been using Brihaspati for. And then we can put directory name, subdirectory name, and maybe a file names also can be added. Okay, so basically any file anywhere in the user's namespace, in user's file system, can be uniquely identified by this. So same file, same name can be used by some other user also, because in that case this string will be always unique and different. And of course, this is the basically the key which will be used to search for the content. So this will be always pointing to a text file which will be describing either a directory. So if it is describing a directory, then this text file will contain what all subdirectories are existing or other file names which are existing. So you can always pick up those subdirectory names or the file names and append them, and then create a new DFS query string and then search for that particular subdirectory or file name. So you can actually recurse through the whole file system of the user. So we also had discussed about UFS. So in fact, the key which I have given here, which we have talked about in the earlier slide, which was DFS : user ID, directory name, file name kind of thing, was in the user's namespace. But actual files or content need not be stored with those. So we can actually create a kind of a universal file system where a content is being indexed by its hash value. Okay, and chances that two files, two fragments will have the same hash value is very low. Even if it is there, we will know that who has published it. In case if it's the users, there is some owner for that. Okay, and so normally we will go to a file. Whenever it's a file, basically we are talking about, it will contain, in fact even a directory inode file which will have list of subdirectories and files. If it is too large, it will go in the same fashion. So normally it will be maintaining that it's a, whenever I am going to search for that key, I will go to the descriptor of that particular file. And I can also search by the hash of this descriptor file, and with that also I can search. Both ways it should be possible. So normally whenever I am going to search for that key will give me a hash value, and with that hash value then I am going to search for the descriptor. Okay, but normally hash value will be used for files, because with the ownership I will be able to figure out whether this belongs to my namespace or not. Okay, even that small finite probability which exists for same hash value being there for two files or two fragments need to be avoided. So this descriptor will normally consist of file name, the description of it, text description, which is an optional thing, and total number of fragments which are there. Then we will have list of fragments for this particular file. So if there are k fragments, there will be k separate hash values, and this can be indexed by the hash of this particular file itself. But remember, there can be two of them, so this thing need to be signed by the owner. So we should know who is the owner in this case. Okay, and hash will also, and there are other options which also need to be added to this. I am not going there because I am just pointing it towards something which I had discussed earlier. Now where these files are going to be stored, that's the question. If I have the hash value, so normally you will take the content hash and you will append a string called copy1, and then you compute the hash of that, and then the root of that will be R1, say, in the number of nodes. That will be the place where you will be storing it. Now since we are actually by design using that copy1 will create copy2, so R1 will publish it to R2, and it will do it by appending instead of copy1, replacing it by copy2, and then computing the hash and then finding out the root node. Now in a DFS, when this is done, it's very important that every entry which is going to be stored has to be encrypted, so that nobody else except the user, because it's his own personal file system which is spread around, nobody else should be able to access it. So normally the content will be, for example, this content will be encrypted by a key, and that key itself will also be pre-appended, but this will be encrypted by the public key of the owner. And then this whole thing will be signed by the owner, so owner can always be sure, or anybody who reads is sure, that this is not being tampered by anybody. And then of course, since this key can only be decrypted by the owner, only he can read this content, nobody else can. And of course there are many other parameters, so I am skipping them here. These we had discussed when we looked at the distributed file system. So in case of a UFS, universal file system, because that's what is the underlying thing, on top of it I will create a DFS. Though of course we do it other way around, but just to keep uniformity and do as much reuse as possible, we always create a UFS. So content, any fragment, any data fragment is always indexed by its hash value, and then these hash values can be further put inside a descriptor file, which then can be indexed by its again hash value, but that hash value is essentially linked with the DFS URI, or these can be directly linked with DFS URI itself. Both way it is feasible, and the system will be can be made flexible to actually use both. So now there are three kind of file modes which can exist in a universal file system. One is that the files or whatever fragment is stored is encrypted, and it has to be digitally signed by the user ID of the creator. Okay. Now normally if this is encrypted, this you should be able to only decrypt it using a key. So you can only get it from the user ID of the creator actually, who has created this and digitally signed this stuff. Okay, either you contact him and get the key for this content. Okay, and normally these kind of files will be for a very short duration. For example, in case of a list server, we have talked about such a file. Okay, or you can actually, this key is also further encrypted and put it in front, and key is encrypted with the public key of the owner, so only owner can actually retrieve this particular file. So this basically will be used for DFS part or list server or messaging kind of mechanisms. And interestingly, even if whatever be the hash, it's not at the root of the content hash where it will be stored. It can be stored at some other place. Okay, the way it happens in list server, it was actually stored at the list server, which is going to be the root of hash of the list name colon user ID. Okay, and of course you are adding substring copy1 and copy2. Now second kind of files which can exist in a UFS system is, they will not be encrypted, but they will be digitally signed. So these are essentially the files which will be of use to us when we are thinking of forming a peer-to-peer web. Okay. So when these files are without encryption, meaning what? They can be viewed by anybody. These are actually for public view. So far you know the URI, you can always find out the hash value, and then from there you can get this file. And these are digitally signed but not encrypted, so you can actually view them very clearly. Digital signatures are required so that you ensure that nobody has tampered with this. These are as what the way the user, the owner wanted them to be actually. So these are basically what we are going to use for peer-to-peer web. So that's our plan for Brihaspati 4 system. And there's a third kind of files which will be without encryption and there will be no signatures. So like a movie file, nobody wants to own it, but it's being dumped. So content hash is the only way to verify the file, but whether it is tempered or not tempered, nobody can say actually anything. Only thing which you can figure out is if you tamper with the file, content hash changes and you can verify with the content hash. Okay. So the publisher of this will not be identifiable. Okay, but tamper proofing cannot be implemented. People may use it, may not use it. It's only for kind of distributing a content without any liability. There can be rogue things sitting inside it. So each file descriptor is going to have 2 copies. Each of the fragment which has been defined, say 1 to k, all of them will have 2 copies actually. Okay, and where these web files will be present, it will be there in distributed file system. Now what we do is we actually have reserved a name www here. So when you actually search for dfs://email id/www, that's a root of the web space of this particular email id. Okay, so this reserved directory name is what is going to be used as the home directory of the user whose email id is here for publishing his content on the web. So any browser, you can start the whole web access for browsing for a user by querying for its home directory. So you will get a file and this file will contain list of either subdirectories and file names, and then you can actually browse through the whole web space of a user. Remember, it's all publicly available. It was intended to be that way, and you can actually can access any published document in this fashion. Okay, and remember, each one of these descriptors for the directories or file names and the fragments and everything, they will all be unencrypted so that anybody can read, but they all need to be digitally signed to ensure it's being tamper proof. See, currently when we access a web, we are going to a server. That server is owned by somebody. It is having HTTPS. So server is whoever is the owner or publisher. Because I am always accessing to a server, I am verifying the server, so I am assuming it's tamper proof. Because we normally create a HTTPS connection now, which is a secure channel on which the content comes back, okay, to the browser. So user important thing, there is no Apache web server which you have put or IIS kind of thing where you are going to put up your content. You don't have to go to a server and ask for a server space for your web page. You can now create a web page on your peer-to-peer in your DFS system, and this is publicly available via DFS and UFS combined. And when you are turned off, what happens to it does not matter, because your DFS content is always there in the peer-to-peer web, and as machines are turning on and off, the content is moving around to whatever is the current root nodes for each fragment or each file. Okay, so whether you are on or off, your content, your public web view is always available to anybody, like even your file system, but your file system is encrypted, only you can decrypt it. So you can log in from other machine and still fetch it actually, and if you have the same user ID certificate is being used there also, you can always retrieve the content. So you actually also see your DFS view as the same view in all your machines. So far your user ID certificates remain same actually, which somehow you have to transfer across the machines. And of course it's a tamper proof system. But now the problem here is this is a static web content. It's not dynamic. Normally we use a lot of JavaScript code and do all kind of animations, and we would like to build up an interactive web page. Now for that actually we have to go further. We have not gone to that part of the design, but that can be incorporated now. That should not be a difficult thing. So, but now to implement this, we need to modify the browsers. So browsers currently only understand FTP, SSH or something. So we have to also now this DFS:// user ID, this protocol also need to be added. This kind of URI should be interpreted by the browser. So you probably have to change the few very commonly available browsers. Probably over the time everybody will build it. And once it is done, your browser can actually browse through your, they will have their DFS API and they can browse through peer-to-peer web, which is created on the DFS system. Remember, there are no web servers now. You are actually working without web servers. They will be slightly slow. I am expecting it that way, but it's still going to function beautifully. Now, how to create dynamic website? So you actually can have dynamic content also provisioned. You can run a service and then you can define an API. This API can be published. So when you give your static page, you can actually link to a dynamic API also. Okay, along with whatever code, JavaScript code which you have published, which can be executed on the client machine. And that client is now acting like a small application which can then use your API specifications to talk to your machine which is providing service. But the moment you are turned off, nobody can provide the service actually. Only you can provide all that thing. So normally these will be done by companies or corporations. So they will actually have multiple servers and then you can connect to any of your JavaScript application running on your browser, which JavaScript application which you fetch from DFS can actually run and can communicate to these small DST layers being created by the companies and can actually fetch the content dynamically and create a dynamic web view for you actually. And of course mutual authentication and everything will be present in this case. Now this is the way one can actually create a peer-to-peer web, and this will be an interesting way of changing the internet.